Alright guys, today we're going to start taking a look at solving quadratic equations by factoring. Okay, so we've spent a lot of time for the past couple of days talking about different ways that we can factor different types of polynomials, or more specifically, factoring quadratics. Okay, today we're going to start going through and actually using factoring to solve them. So we're going to be adding one extra little step. All right, the process that we're going to be going through to do this is first we have to set the quadratic equal to 0. When you're just factoring, there's no equal sign. It's not an equation. You can't solve it. Okay, you can only rewrite it via factoring. But if we're solving it, we have to set it equal to 0. Okay, and there's a very important reason why it has to be set equal to 0 that I will explain in a minute. After we've got it where it's set equal to 0, we want to factor the quadratic as completely as we possibly can. Okay, it's going to be easiest if you have it in standard form, but we're going to go through and factor it completely at that point. Third, we're going to set each factor equal to 0 to solve. Okay, that's why we had to set it equal to 0 in the first place, because we're using what is called the zero product property, which mathematically states that if you multiply anything by 0, the resulting product must also equal 0. So that allows us to take a big polynomial and write it as the product of two or more smaller polynomials, because we can find the zeros, otherwise known as the solutions, okay, because we're solving, by finding a component 0 from within that factorization. Okay, so we're trying to go through and factor it, set each factor equal to 0 so that we can find all the other zeros. Okay, once we find those zeros, you can check it. You can do that by either graphing. You can go through and you can identify where the x-intercepts on the graph are, or you can use direct substitution to do that. Okay, so we're going to go through a couple of examples. The first one that we're going to look at here is example 1, where we're going to be finding the solutions for x squared minus 5x plus 6 is equal to 0. Okay, I know that I'm going to be solving it because this is equal to 0. All right, so what I'm going to do is I'm going to identify what type of polynomial this is and then determine the most appropriate way to factor it. So this is a quadratic because it has a degree of 2. It is a trinomial because it has 1, 2, 3 terms, and it has a leading coefficient of 1. So I can factor it like a quadratic trinomial with a leading coefficient of 1, which really just means looking at factors of my C term that will combine to my B term. All right, so I need factors of a positive 6 that combine to a negative 5. Okay, so in this case, I'm going to say negative 2 and negative 3. Okay, because negative 2 times negative 3 gives me a positive 6, but negative 2 minus 3 gives me a negative 5x. All right, this x squared, okay, is really just x times x. All right, so this means that I can factor it into x minus 2 times x minus 3, and that's set equal to 0. So using the zero product property, if this is equal to 0 and we multiply it by whatever that is, we're going to get 0. So it's a true statement, so that would be a solution. Okay, so what I'm going to do is I'm going to take each one of these factors and kind of set it equal to 0. So I'm going to take this x minus 2, set it equal to 0, add 2 to each side, so x equals 2 is one of my solutions. The other one is going to come from here, where I'm going to say x minus 3 could equal 0, add 3, so I'm going to get x equals 3 over here. All right, so those are my two solutions. So my solution set is going to be x equals, fancy squiggly brackets, the smallest number, 2, the largest number, 3, and close my squiggly brackets to indicate that those are the two solutions for this one singular quadratic. All right? So let's go and look at example number 2, where things are getting considerably more challenging looking. Okay? So in this problem, we're still trying to go through and solve it, right? But it's 2x cubed minus 20x squared plus 98x, and it equals 8x squared. Well, first things first. What does this need to equal? It needs to equal 0. So I'm going to subtract 8x squared from each side. So I want to only add and subtract my like terms, so I'm going to take that away from my other x squareds. So this is now 2x cubed minus 28x squared plus 98x, and it's equal to 0. So guess what? It's now equal to 0, and what else can I do? I can start to factor it. When I factor, I always want to start looking for a GCF, okay? Especially when it's kind of funky looking like this, where it's a cubic trinomial, right? But this is 2, 28, 98, those are all even numbers. I can take out at least a 2. X cubed, x squared, x to the first, I can take out at least 1x, okay? So then what's left over? Well, then I just have an x squared. Half of 28 is 14, so minus 14x, and half of 98 is 49, so plus 49, okay? Now, inside the parentheses here, do I have a factorable quadratic? Absolutely, okay? So this is going to be able to get factored. This is a quadratic trinomial with a leading coefficient of 1. So again, I can just kind of look at factors of 49 over here. So what are factors of positive 49 that combine to negative 14? Well, probably negative 7 and negative 7. Okay? The x squared is obviously just x and x. So this can be factored into x minus 7 times x minus 7. Okay? Do I still have the 2x? Is that still a factor? Absolutely. So I have a 2x over here, and this still equals 0. But what can I go and do now? Well, I can find all 3 possible zeros. Okay? So I'm going to take each one of those factors, 2x, x minus 7, and then a second x minus 7, and set them all equal to 0. So when is 2x going to equal 0? Well, when x is 0. Just divide by 2. When is x minus 7 going to equal 0? Well, when x is 7. Okay, and I'm going to see that this is really a repeat, so I'm going to end up with the same value again. So if x is equal to 0 or 7, this will equal 0. So that's going to be our solution. So we would go and write our answer is x equals, fancy squiggly brackets, smallest one 0, other one 7. There's no need to go and write it twice, but the solution set for this cubic polynomial is going to be 0 and 7. All right, so let's go through and take a look at one more solving by factoring. Okay, so this one, we've got ourselves a 4x squared plus 49 equals 35x. I'm trying to solve this. The giveaway is there's an equal sign here, okay, but it's not equal to 0. So I need to go and subtract 35x from each side. Okay, I don't have an x term, a linear term on the left-hand side, so this is now going to be expressed as a trinomial. So I've got 4x squared minus 35x plus 49, and that equals 0. All right, so now I can try and factor this. This is a quadratic trinomial, and it's got a leading coefficient of 4. Does it have a GCF? 4 and 35, not so much. So not even going to bother looking at 49. But what I can do is I can attempt to factor this by what we learned the other day, which is factoring by grouping. Okay, so maybe I take the 4 and the 49 and I multiply those together. Okay, am I going to get kind of a big number? Probably, but it's all right. We'll work our way through it. It's 196. Okay, 196 is not a number that I know a lot of the factors of. So I'm probably going to want to use a calculator at this point to start playing around with some numbers. Okay, so I'm looking for factors of 196 that will add up to negative 35. So I already know that they're probably both going to end up needing to be negative, okay, because if they're multiplying to a positive number, they kind of have to have the same sign. But I'm going to take my calculator and I'm going to type in 196, and I'm just going to randomly guess, is it divisible by 2? It is. I get 98 and 2. Well, can 98 and 2 combine to get me 35? Probably not. Okay, 196, is it divisible by 6? Nope, I'd get 32.6 repeating. So 196 divided by maybe 8. 24.5, close, but it's still not a factor. 196 divided by, should I try 10? No. Should I try 12? Probably. Nope, I get 16.3 repeating. 196 divided by 14 maybe? Well, I get 14. Well, 14 and 14, well, maybe that's getting me a little bit closer, okay? But you see how we're really just having to go through and kind of take our best guess as to what this could possibly be? Well, we just got to keep trying. So 196 divided by maybe 16, 12 and a quarter, nope. 196 divided by 18, 10.8 repeating, nope. 196 divided by some other number, 22, I don't know. Doesn't seem to be like I'm having a lot of luck. That is okay. There's going to be certain times when you're doing certain problems where it takes you a minute to go and do it, okay? You just got to be patient, just kind of guess and check, see what you can come up with, okay? I promise you'll figure it out eventually, all right? So kind of jumping around and doing different numbers hasn't really helped me out a whole lot, okay? So what about if I tried just going 2, 3, 4, 5, 6, okay? Have I already tried 3? Yeah, 196, I've already tried 4, 6, maybe 7. 196 divided by 7 is 28. Oh, 7 and 28. Maybe that'll be the thing that breaks the deadlock here, okay? You just got to play around with it. It's okay. 7 and 28 will combine to 35 if I make them both negative. They'll get to negative 35. So, hey, I think we figured out what we should be doing. So, let's go through and rewrite this middle term. So 4x squared, but then I'm going to go and rewrite it as negative 7x minus 28x, and then I still had that plus 49 at the end, right? Okay, and it equals 0. So guess what I can go and do now? I can go and do some factoring by grouping. All right, so between 4x squared and negative 7x, what can I take out? Well, really just an x. What's left? 4x and then minus 7. Over on this side, 28 and 49, well, I can take out a 7, but because that third term is negative, I probably need to take out a negative 7. So that'll get me a 4x and minus 7. Okay, so does this one match this one? It sure does. So let's start doing some factors. So we've got one factor of 4x minus 7, and we've got another factor that's x minus 7. But we also need to go and say this is going to be equal to 0, because what are we doing? Solving. So once we've gone and we've split it up that way, I can go and take a look at each one of these factors and set it equal to 0. So 4x minus 7 will equal 0 when 4x equals positive 7, because I'd add it to both sides, and then divide by 4. So x would equal 7/4, and just leave it as that improper fraction. Over on this side, I could say x minus 7 will equal 0 only when x equals 7, okay? So what is my solution set? It would be x equals, fancy squiggly brackets, 7/4, and then I would go and have 7 as well, okay? So even if it takes you a hot minute to go through and figure out some of that stuff, sometimes it takes me a hot minute to go and figure that stuff. Just use your calculator, try and be as efficient as you can, and if it takes you a minute, that's okay, all right? So this is how we're using factoring to solve quadratics.